Hess's law. What is Hess's law? Sometimes when we are trying to find enthalpy of a reaction, which is delta H for a given reaction, it is difficult to measure. Not every reaction enthalpy can be measured, right? We cannot do calorimetry for every single reaction. So how do we find enthalpy for those reactions? These can be calculated by manipulating the equations for other reactions with their known delta H values. So instead of doing this particular reaction directly in a calorimeter, we manipulate some other equations and use their delta H value to find delta H for our reaction of interest. For example, when chemical equations are added together to yield a different chemical equation, the corresponding delta H values are also added to get the delta H for desired equation. For example, if I do A plus B gives me C, I know that delta H for this reaction is H1. I do another reaction which is, let's say, C plus D gives me E. Okay, and delta H for this reaction is H2. And I want to find, if I add these two reactions, what do I get? A plus B, C and C will cancel out, plus D gives me E, which means what is delta H for this reaction? I added the top two reactions to get this, which means the delta H for bottom reaction is also sum of the top two reaction, H1 plus H2. That is called as manipulating two different reactions to find delta H for a desired equation, and this is known as the Hess's law, when we manipulate equations to get our desired equation. Okay, let's see how we can manipulate these equations. There are some rules for it. For example, let's say rule number 1, when an equation is reversed, the sign of its enthalpy is also reversed, it changes. Okay, for example, if this is given to us, nitrogen plus oxygen are reactants they produce when they react to a nitrogen monoxide. The delta H for this reaction is given to us 180.6 kilojoules. The question is asking what is the delta H for this reaction. Now you need to find what is the relationship between these two reactions. Here 2NO is breaking down to give us nitrogen and oxygen. Okay, so these are my products and this is my reactant this time. So what we did here, we reversed the reaction. The bottom reaction is reverse of the top reaction. If you reverse the reaction, the sign of delta H is also reversed, which means delta H would become negative. If you flip your reaction, your delta H becomes negative. Because this was positive, it becomes negative. If this was negative, the bottom would become positive. Okay. Rule number 2, when the coefficients in an equation are multiplied or divided by a factor, the enthalpy value is also multiplied or divided by that same factor. For example, calcium plus half O2 gives us calcium oxide. Delta H for this reaction is minus 635.1 kilojoules. What would be the delta H for this reaction? Now you need to find the relationship between the top and the bottom reaction. If you pay attention, this is 1 calcium, 2 calcium, half oxygen, 1 oxygen, 1 CaO, 2 CaO, which means the bottom reaction is 2 times of the top reaction. If I multiply the top by 2, I get the bottom reaction, which means what happens to my delta H? My delta H is also multiplied by 2. So delta H for bottom is 2 times of this, which is negative 1270. Last rule, third rule, is when reactions are summed together, the enthalpy of the overall reaction is the sum of enthalpy of its component reaction. For example, the first reaction, carbon plus oxygen gives me CO2, delta H is this. Second is CO2 plus carbon, CO2 gives us carbon and oxygen, delta H is this. Now if I add these two reactions, how do you add reactions? You look at one reactant at a time. Carbon diamond is nowhere else in any other reaction. That's my first reactant. My second reactant is oxygen, which is right here. I also have oxygen in the bottom reaction. In the first reaction, it is a reactant. In the bottom reaction, it's a product, which means reactant and product will cancel each other out. Here I make one oxygen and here I use one oxygen, then I end up making one in the bottom reaction. So They cancel each other's effect. Second reactant is CO2. Third reactant, I mean CO2, but I also have CO2 in the top reaction. So I make one and then I use that in the second reaction, which means I have no other reactant. So carbon diamond is changing into carbon graphite. That is my reaction. What would be delta H for this? I added the two reactions, reaction number 1 and reaction number 2. So which means I should also add, if this is H for 1, this is H for 2, I should also, my delta H will be H1 plus delta H2. So it is negative 395.4 plus 393.5 kilojoules. That would be my heat of the reaction for bottom reaction. Gives me negative 1.9 kilojoules. That is Hess's law. Okay. Questions would look something like this. Using the data below, calculate delta H for this reaction. Okay. The data is given reaction 1, reaction 2. How do we solve these questions? You look at what you want. I want carbon solid. So I'm going to find which of the two reactions here has carbon solid. The first reaction has carbon solid. So I'll write my first reaction. How many carbon solid I want? I want 1. I have 1. I want them on the reactant side. It is on the reactant side, which means I just don't do anything to the reaction. I write it as it is. And delta H1 is given to me. Okay. Next, I need half oxygen. Where is oxygen? Oxygen is in the top reaction and the bottom reaction. Because it's common to both reaction, I will leave oxygen for the end. I will figure out and balance my oxygen at the end. I'll focus on another reactant or product. Next, I have CO. Out of the two reactions, top and bottom, where do we find carbon monoxide? Carbon monoxide is in the second reaction, so we'll move on to the second reaction. The important thing here is, where is carbon monoxide? Where do I want it? I want it on the product side. Where is it given? Reactant side. How many do I want? I want 1. How many do they have? 1. Which means I will have to flip this reaction. So how do I flip it? CO plus half O2 comes from CO2, and this is delta H2. Because I flip the reaction, the sign will also become flipped. This delta H, let's say this is delta H for here, will be equal to delta H1. This delta H here will be equal to negative of delta H2, which is negative of negative 283, which is positive 283 kilojoules, because I flipped it, right? And the top stays as it is. Now we will add the two reactions and see if our oxygen comes out to be working for us or not. Okay. How many carbons are here? 1 carbon, so I write it as it is. Then I go to oxygen. I have 1 oxygen on the left side and half an oxygen on the right side, which means I'm using 1 but I'm ending up making half. Whenever you have 1 on the reactant and on the product side, the same chemical species, we subtract them. So this was 1 minus half, which gives you half oxygen. Okay. Next I go to the reactant. First we'll only focus on the reactant side, everything on the left side of the arrow. This is CO2. How many CO2 do I have here? 1. I also have CO2 right here, 1, which means this is a reactant and product, they cancel each other out, so I do not have any more CO2 left. Moving on to the right side, what's left on the product side is only carbon monoxide. Okay, so the reaction after adding these two is carbon solid, half O2 gives me CO, which is exactly what I wanted. The question was asking for this. So what would be delta H for this? I added the top two reactions, so delta H would also be added, which is 393 kilojoules plus the positive 283 kilojoules. That would give me my delta H, which is basically negative 110 kilojoules. Okay, so the aim is to flip reaction, to multiply reactions, and to add reaction somehow, so that we can end up with the same reaction that the question is asking. Let's try one more. Use delta H values from equation 1 and 2 to calculate delta H for vaporization of ethanol. I need to find this reaction. Again, how do you focus on the reaction? The only focus on what you want. I want this. Okay, C2H6OL in liquid form. Where is this in the liquid form? In the second reaction. I want it on the reactant side. Where is it? On the product side, which means I have to flip the reaction. Let's also look at the quantity. I want 1. This is 1, which means I don't have to multiply, but I do have to flip. So I'll flip it. C2H6O liquid gives me carbon solid. You also have to pay attention to the phases. Okay, half O2 gas. Because I flipped the reaction, my delta H will now be flipped as well. It will become plus 277.6 kilojoules. Then I look at my second thing that I want in my reaction, C2H6 gas. Where is it? It is right here in the top reaction. I want it on the product side. This is already on the product side, so I don't have to flip it. I want 1. This is also 1, so I don't have to multiply with anything, which means I can rewrite this reaction as it is. So on the product side, what do I have? C2H6O in gas form. The reactants are 2 carbon solid, 3 hydrogen gas, and half O2 gas. What would be delta H? I did not do anything to my reaction number 1, so it will stay as it is, negative 234.8 kilojoules. Now forget about everything else and just add the 2 reactions. Okay, if my final answer does not match with what I want, then we'll think about everything else. But for now, only focus on the reaction you want, the question that the question is asking for, and only focus on the reactant and products of those. Okay, now let's see. C2H6O liquid. Is there anywhere else that we see it? No, so I will rewrite it liquid form. Then I move on to, we are only focusing on the left side of the arrow for now. Okay, I need 2 carbons here. The 2 carbons are also here, solid, so they cancel each other out. Reactant and product. One is reactant, another one is product, so they cancel out. Then I have 3 hydrogen on the reactant side. I also have 3 hydrogen on the product side, so they cancel each other out. I have half oxygen on the reactant side, half oxygen on the product side, so they cancel each other out, which means I have nothing else on the reactant side. On the product, C2H6O gas. Everything else is also cancelled out. That is exactly what I wanted. The question asking me this, I have this. How did I get it? I added the top 2. So I'll add these 2 numbers that I have. Delta H will be plus 277.6 plus negative 234.8, which eventually gives me my final answer in kilojoules. Important thing to make sure is this is kilojoules, this is kilojoules. So when you're adding them, make sure you're adding the same units. If they're not in the same units, you have to convert them into same units. And your final answer is 42.8 kilojoules, and we're done. Let's try one more. Use delta H values for equation 1, 2, and 3 to calculate delta H for following. This is what I want. Only focus on what you want. I want C2H2. Where is C2H2? C2H2 is only in the top reaction. Okay, I want it on the reactant side. This is a reactant. Great. I want 1. This is 2, which means I have to divide this by 2. So you have to divide everything by 2. Okay, which means I will divide everything by 2. So this is 2 by 2, which is 1. This will become 2.5. This will become 2. This will become 1, which means delta H will become this divided by 2. Okay, I didn't flip it. Let me just make it cleaner. Okay, I did not flip this reaction, so it will stay as it is. Only thing I did is I divided everything by 2. Sorry, because I divided it by 2, it becomes 1. You can rewrite this equation, by the way. I just don't have enough space here. Okay, next, what do I need? I need 2 hydrogen. Which reaction out of the 3 has hydrogen? It's the third reaction. I want 2. I have 2. I want on the reactant side. It is already on the reactant side, which means I'm good. So do I do anything to this reaction? The answer is no. I just take it as it is, which means my H3 is whatever it is, and I'm done with this I'm done with this. The third thing I need is C2H6. C2H6 is right here in the second reaction. I want it on the product. This is on the reactant side. Okay, and which means I have to flip the reaction. If I flip the reaction, the sign will get flipped, so this will become positive. Second thing, I want only one. This is 2, which means I have to also divide all of this by 2, which means I also have to divide this by 2. So the sign is flipped and it's divided by 2. Okay, so let's rewrite all these three equations. They are like this: C2H2, so I divided by 2, everything. Nu is divided by 2. The second reaction, I flipped it and I divided it by 2, so it gives me flipped and divided by 2. The third reaction is as it is. Now if you add these reactions, what do we get? We start with C2H2, nowhere else, so C2H2. Then I go to oxygen. I have 5 by 2 oxygen here, 1 oxygen here. Okay, so that, and on the other end I have 7 by 2 oxygen. So if you take 5 by 2 and you add 1 into it, it gives you again 7 by 2. Okay, which means this and this cancels each other out. Next I go to reactant CO2. CO2 is also present on the product side. This is 2 CO2, this is also 2 CO2, so it cancels out. Then I go to water. This is 3 water on the reactant side. I have 1 water on the product side and 2 water on the product side. So 3 water reactant, 1 and 2, 3 on product. They cancel each other out. Then I have hydrogen. There's nowhere else hydrogen, so plus 2 hydrogen gives me nothing else left on the product side except C2H2, which is exactly what the question wanted. How did I get it? I added this, this, and this. So you add all these three together and that gives you your final answer in of delta H, and you're done. Okay, so what is the important take home from here? Always focus on the reaction that the question wants you to solve for. Get one reactant at a time. So I want this reactant, find the equation. I want this, find the equation. I want this, find the equation. If you're looking for a particular species and it's common, it's present in first, second, and third reaction, leave it for the end. Do not focus on it. Okay, and then add all the reactions together and see if it matches with what you want.